Good morning. Happy Sunday. Seems like only yesterday. Another Sunday. Getting everything wired up. All right. Phone's about there. How is everyone today? Hope you're all doing well. Oh, you know what? I forgot to set up the little countdown thing. That's right. Let's go ahead and fix the other stuff. There we go. We got that one. Godot. Fix Godot editor. This is the stuff I have to do every day, right? Configure OBS. Day after day after day. OBS could only detect that I only have one Firefox window. I should just use that one. Alright, and Twitch on my phone thinks I'm streaming. Twitch on my browser does not. Gonna reload the browser. Okay. Let's check over here. Okay. Well, so just to start this out, we're not going to be building our own test later. Turns out, Nickel already did. And while it would be fun, I think it would be a lot of fun. Well, I think it would be. We're just not going to do it. We're going to build a game. We're not going to build a test later. We're going to build a game. So, Tesla Island is going to change a bit. It's going to pull in Lyon. 2D graphics rendering on the GPU using tessellation. Using GPU, yep. Now Lyon here depends on these algorithms or these dependencies, and that's it. It's not actually wired up to any GPU library, etc. It's just for the tessellation, which is fantastic. So we'll be using that. I gotta send a message real quick. All right. Yeah, let's get started. I'm going to try to use this. They do have a wiki, and I think the wiki actually tells quite a bit. Also, in the tessellator section, oh, that's the algorithms. And look, that one has holes. That one has holes. It's exactly what we want. There. Sorry, I didn't have my headset on correctly. I mean, it even looks like it does the deduplication. So I'm not sure what the tolerance here is going to give us. Let's go look at the fill options. Fill rounded rectangle. Oh my goodness. That is so cool. They've got so much stuff in here.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight.
The tessellator's code itself also has some inline comments that explain how the different cases are dealt with. Got it. We vaguely refer to the tessellator in this wiki to talk about the algorithm that tessellate a path into a fill operation. The tessellator's job is to output a sequence of triangles in a way that is practical for consumption by various GPU APIs such as OpenGL or Direct3D. The tessellator itself is self-contained and independent of underlying GPU backend, which is perfect. Tessellation primitives are all implemented in the Lyon tessellation crate under the tessellation source folder in this repository. We use triangulation and tessellation interchangeably. Okay. The tessellator takes as a parameter a list of edges sorted from top to bottom. Interesting. Is it top, bottom, left, right? All coordinates are internally expressed as fixed point numbers. The main tessellator loop accumulates all of the edges that start at the current position of the sweep line, processing all of the accumulated events at once and move on to the next position. This processing the current position part contains most of the interesting logic. We first go through the sweep line to find edges that terminate at the current position, remove them from the sweep line, and add new edges we've accumulated depending on the order of the edges. Okay. Rendering curves, current and future. Stroke tessellator is a simplified implementation of strokes that extrude a strip of triangles along a path. Oh, ooh, interesting. Interesting. Because these overlapping areas are covered by triangles several times. Okay. Interesting links, yep. And it's got links to Skia. Alright. It's a little quiet out there today, isn't it? So I'm going to test this, make sure we're... Okay, so this is where we're starting. We're trying to get this shape here to not have that leftmost triangle that the green line is pointing at. Let's just jump into coding. It's a little interesting in that the documentation suggests that we should pass this in top-bottom, which makes sense for the algorithm they're doing. Sorted from top to bottom. A list of edges sorted from top to bottom. The fill tessellator actually comes later in the pipeline, if I remember correctly. So we go through this, yes, there's a bunch of subcrates, and if we look at re-exported bits, they have this little pipeline here If I select it, you can actually see what this is. So there's an iterator of path events that then fills the fill tessellator. So you can have move to line 2 points, etc., which is kind of what we have with our shapes. Our shapes could implement iterator of path events. We give that to the fill tessellator, to the geometry builder, etc., and then we're done. Magic. And we got little dude with a mustache. Perfect. Alright, let's start with iterator of path events. Actually, I'm a little curious about the stroke tessellation because I've been wondering about certain edges. So I think it would be neat to have a certain texture around the edge of the island, and I think I could do that with a shader. But on some devices I might need some other triangles there. Simply generates a strip of triangles along the path. This is perfect. This looks really good. Input iterators. The path tessellators are not tied to a particular data structure. Instead, they consume iterators of flattened path events. A path struct? Oh, do tell. Interesting. I like the idea of being able to use using a curve for this. It would increase the number of triangles though. So it seems like, goodness, we might be able to get away with like simplification and stuff like that all just tossed into this at once. Path builder. Move to line 2. Quadratic Bezier 2, cubic Bezier 2. Lotka 8, good morning. How are ya? My day is starting. It's dark and smoky out. Don't know if I want to use the path builder or not. I mean, less code is less code. there's also something to be said about not depending on other code too much. All right, and then if we did want to simplify, what would we do? Let's just keep with ours for a bit. If we wanted to explore with this stuff later, we could. The curves really are tempting me at the moment. Basically, this is a means of taking a hull of an object, the outer perimeter of a shape, and converting it into triangles. So that we can give it to a GPU, or Godot, which then gives it to a GPU. Yeah, we're gonna skip the path builder. The output geometry builders. Basic geometry builder, fill geometry builder. And what is the difference? Flattening and tolerance. Most tessellations in this crate currently operate on flattened paths. Alright, so I think it's good that we're still simplifying ourselves. Alright, so let's start this. Iterator of path event. How do we create a path event? Is that in path? Where is that? Building and tessellating an arbitrary path. Okay, so in this case, they're using the path builder, which we could do. I was trying to get away from that, but it's fine. So we're going to use the path builder to, basically, our shapes will provide an iterator, which I think this path builder can provide. Or at least it can provide a path. Then the geometry and the tessellator. Tessellate path, yada yada, fill options default, etc. Good. Okay, now let's try it out. Oh look, it's still using the 2015 stuff. And yesterday we were actually looking at, somebody had asked a question, where do we start with Rust? I've done a bunch of exercises, I've done some stuff. What do? I don't really have a project. And this is an example of what to do. Right? They have a bunch of easy help wanted stuff in here. Help wanted, help wanted. Maybe you're good at geometry and all this stuff here. And maybe you're not. Take a look at these and see if you can help out. But if you're in that position where you don't know what to do, and find a crate that has this sort of stuff in it. Okay. Coming back to the docks here. Yep, we're going to create a path builder from our shape. Oh, we do an into on this. It shouldn't know path or shape. Interesting. Let's just pull the whole thing in like that. Not be too careful about that. If it becomes an issue, we'll change it. All right, give this a moment. There we go. Import center Leon path. Good. Now where's this builder? This builder is in Leon path builder. It looks like it's off of, we just do path builder there. Seems like a genre people would like. I think it's something that my kids would play, you know? Something I could have fun with, something the kids would have fun with. I got a bunch of kids and I think that kind of it's a bunch of their kind of play styles, building versus exploration versus like dungeon sort of stuff. That's sweet of me. So I guess at the beginning we move to the first point. Interesting, that's a point 2D. That's a Euclid shape, Euclid type. Can we not go into that type from here? Ooh, interesting. I don't really want to go into a tuple. I wonder if instead we should make it. So let's look at the Euclid crate real quick. Let's look at the repo. All right, mintvec. All right, let's clone that. Oh, interesting. Would that be for all 5 of these? Or however many there are? To make Mint available? Features. Will I be launching the game commercially? I think that's the purpose of most games, actually, is to make money. So, commercial in some sense. I would love it if I could, become like a full-time game dev, but it's more of I'm kind of passionate about this project, so it's kind of one of those sorts of projects, and if it happens to roll into commercial stuff, that's great. However, am I doing this part-time right now? I'm kind of doing it to learn Rust, quite frankly. And I do it for a couple hours before work every day. So a couple hours here, a couple hours there, and it's pretty consistent. But if you look at the legacy ext repo there, if you look at the tree on there, the sources, there's a number of crates in there that I've extracted from kind of the game engine. So while a bunch of this is kind of getting extracted out into its own thing, I think the core of it is still going to be kind of closed source, whereas a lot of the fringe stuff is going to be open source. What did we make the other day? The other day we made this. So a lot of these things that we're making that could be useful to other people are being made available. That, and as we go through, if we find things that we could help out in the community and do a little bit, as long as it's kind of like in the same direction, then we'll do it. What are we doing today? I am looking at Lyon. So there's this crate called Lyon. It's French for lion. And it's a tesslator. It does, I think, exactly what we want, so we're just going to use it. We're not going to be doing our own tesslation anymore. Even though it would be fun, our goal isn't to build a tesslator, it's to build a game, so we're going to do that. However, we might actually come in here and do a little work on Lyon as we do this, because I want to use a different set of points. So we're going to look at that repo. Do they have anything in here about mint? They don't. What about closed issues? Basically, I want to be able to pass an option down to Euclid. I don't think I can do it from here. Oh, what do I need tessellation for? We're basically scanning noise and creating an outline of the noise shape. Okay, and then we need to take that shape and give it to a GPU. But to give it to a GPU, GPUs speak in triangles mainly, right? So we have to tessellate. We need to create triangles from shapes. So, all right, let's figure out how we can pass that through. Does this mean I have to fork just this one repo, right? Yeah, it's all in the same one. Great, it's a workspace. All right, here goes the forking. I like their fork copy thing. That's really cool. Did I use Perla noise? Yes, I did use, well, I used fractal Brownian motion from the noise grade, FBM. Yeah, you could call it Perla noise. I think it's the same thing. Actually, I think it's more of a simplex noise. But I'm not sure. All right, so now we've got this. Let's give it a clone. Code. Copy. And then over here. See, this is the problem I want to solve. I want to make that to work. Going from mint type into this other one. A noise crate. Yeah, there's got some noisy crates over here. There's a ton of stuff. There's noise, there's like fast noise, SIMD noise. Yeah, this is the one I was thinking of. SIMD noise is really fast. RAN jitter. Interesting. Purest implementation of the noise protocol framework. What is that? Poltergeist. Oh my goodness. You're using Stego's noise from C. Oh, cool. All right, so back to our cloning. Hopefully we've got this thing cloned. Okay, that didn't take long. Now inside of here, so we've got the top level cargo.toml file. Oh, it's not a workspace. All right, so we're gonna have a feature here for Mint. And then everything that we need to pass this through. We're gonna do this slightly different. Alright. What are the other ones we need? No, not like that. Go back. Some implementations are too complex. Oh, interesting. Turbo Dave, good morning. How are you doing? See, this is different than what I just cloned, isn't it? Because here's tessellation. That's a cargo. Oh no, I guess I got the whole thing. It is a workspace. Got it. It's a workspace and a crate at the same time? Oh, fancy. That is neat. It's raining non-stop? Oh, we could use rain. $300 square foot house? Sounds cozy. Alright, so in here... So which of these actually need features? Serades, Euclid Serade. Just gonna tag. Let's see. I don't even know what file that. Oh. I'm looking for the Euclid crates in here. Which crates inside this project? Well, which crates inside this workspace use Euclid? Because we want to pass a feature flag through them. Looks like only one does. And that's geometry. Okay. We do it like that. Pass that feature flag through. But we have to do the same thing for whomever is using geometry. We got two. No, just path. Path is using it. All right. Okay. So if we have that, that's good. Now who uses the own path? You can see where this is going. Oh, handful. Algorithms, extra, path, SVG, and tessellation. Because path is long path. Those I'll use it. It's just features. Okay, that'll pass it through there. Go to the next one. Ah, this one does have features. Good. I wonder why the gap there. Maybe it's just easier to see form. We'll put that back. Give that little space there. All right, now we have 4 elements to keep track of. Where's my pen and paper? Got my handy dandy notebook. Watched too much Blue's Clues when the kids were small. All right, so we just changed which packages. SVG, extras, algorithm. Okay. Algorithms. And tessellation. Okay, let's find those. So extra also uses SVG. All right, so we'll pass that down through. That's it for SVG. And what about extra? What's that called? It's called Lion Extra. And that's only used by tessellation. Oh, you're dealing with spaghetti SQL queries. Ugh. Oh, that sucks. Alright, that was extra. And that one's alone. Alright. And tessellation.
Are you scared? I am you.
That's used by test 2. Interesting. I told you it's a backend project, and you realize it's a SQL query spaghetti project. Simply a DevOps guy who tried to write Go, but couldn't do logical operations in Go. Oh wow. Ooh, well that's fun. You really hate raw SQL now. Oh no. All SQL query starts with query 1, query 2, query 3. Oh man. A lot of copy paste, it sounds like. Alright, now we have to do SVG. Algorithms, mins, extras, is it only 5? 1, 2, 3, 4. I feel like I'm missing one. Oh, path. Okay, path actually goes down through tessellation, etc. If I remember correctly. There's just too many, and no service is written. Everything is done under one repository structure. Oh wow. So you do consulting? Hey, Game Dev Unknown, how are ya? Oh, that's cool. I think it'd be fun to be a freelancer again. Oh. Aren't these all supposed to be 0.16? It's 0.16. Where did that get released from? Is it not master? Is it some other? Here's 0.16. Alright, where are the branches in this? Oh, there. What at 16? Okay. Maybe we should do stuff over there then. Good stash. What was it called? What at 16? Now with more correct spellings. Did I know C++ before learning Rust? I did, yeah, but I haven't used it in a decade. Oh wow, a little bit more than a decade. 13 years. Oh. I know it's unmerged. I don't want to merge it. Git restore. There we go. Git checkout. All right. Okay. You started to think that some people should never write Rust or Go before learning Java and C. I don't know. I think that the people should seek out mentors when they don't have them. And it's part of the reason why I was streaming. Is when I started this a year and a day ago. Yesterday was my cake day. Yeah, what's the difference? It looks like it's just a 15 to 16 here. Did I have an actual cake yesterday? No, the people around here that build the cakes, are not entirely like an uber fan of my twitching. So oh, they're getting packages and coroutines. I did not hear about that. Wow. Yeah, that looks fine. Was that path? Yeah, it was path. Anti-online streaming cake builders. Yeah, when I take a day off of doing this, they celebrate. But you know, I think it ends up. If I can eventually get like a gig doing Rust or something, or if this game builds into something, because given the kind of environment, just trying to not have all my eggs in one basket. Okay, I think that's the last of the merges. Get cargo build, cargo check. That build. Let's try to do a check. Features mint. Is it feature mint? Ah, good. The package Leon depends on Lion Tessellation with feature Lion Extra, but Lion Tessellation does not have these features. What's it actually complaining about here? Gomozo! Wow, thank you. Thank you for the raid. And everybody welcome. We are currently building a game. I guess that's like what I do whenever I'm trying to learn a new programming language, is I build a game. And for the last year I've been learning Rust, so welcome. And if you're interested about the setup, anything like that, we do have a number of commands. Man, I love Rust. I've been coding for over 20 years, and Rust solves so many issues that I've had in other languages. I mean, I've done like MMO backends with Rust. Excuse me, not in Rust, in Java. I've done like big company like Messenger backends in C++, stuff like that, and Rust just solves so many issues right out the door. And how's everybody's Sunday? The other thing that we kind of do on this channel is we tell bad jokes. They have to be clean bad jokes, though. Who earns a living by driving their customers away? A taxi driver. Puns are preferable. And if you want to spend your channel points, you don't recognize the symbol, it's a lifetimes in Rust. You can tell bad jokes. Or good jokes. Good jokes cost half as much. So welcome everyone. The current project today is we are working on random island generation and tessellation of noise. So this is a really, really simple version. We are trying to debug an issue that we're having, and we were coming up with concave shapes, which a number of the islands will end up having a concave face here or there, or portion of it. Hey, good morning, Pookie. Yeah, they have to be kind of clean. Good jokes. Your son kept chewing on electrical cords, so you had to ground him. He's doing better currently and conducting himself properly. That's a good one. We had some good ones yesterday too. Let's see, I think Museum was on like a roll. Was it yesterday or the day before? Oh, yes. This one's actually from Bare Knuckle. Why is the obtuse triangle always upset? Because it's never right. All right. So we were trying to, back to the example, get rid of that triangle on the left. So we're pulling in this crate called Lion. It's French for lion. And this crate here, I thought they had a little bit more text on this portion here. But really it's a crate designed for tessellation. So you can take some paths, some shapes, whatever you have, and tessellate them for a GPU. I think the creator of this crate was a Mozilla Dev, is a Mozilla Dev, I don't know, never really interacted with him, and did Rust over there. So we're going to be trying to use this. At the very moment, we are trying to get the mint types available to be used by this crate, because this crate ends up using the Euclid crate, and the Euclid crate has a new feature called mint. And the mint crate, I know, it's a rabbit hole, bear with me, but the mint crate has math interoperability shared types here. And so there's a lot of types that are defined in here, which we're using in the core of our game server. Right, we're using this for generating for capturing some of the noise, all that, and we would like to be able to use this inside of Mint, or excuse me, inside of Lion. Now, Lion has Euclid. Euclid has a feature called Mint. We're trying to turn that on at the moment. So, unmerged paths. Oh, interesting. Quit everything, good status. All right. So we want to turn on a feature called Mint. But we don't have it wired up quite right. Package Leon depends on land tessellation with features Leon Extra, but Leon Tessellation does not have those features. Oh, did I butcher that? Mint. So we have Leon Tessellation Mint. That. Those all look good. There was a guy on YouTube who put Rust game logo on a Rust video. So here we have extras. Oh, how do we do this only if extras is available? Because I guess what this is saying here is that extras enables that crate. And I don't know how to combine these two. Because if we remove extra here, oh, that's not it. Okay, I misinterpreted that. Let's look at the other cargo file. So the features in here. Oh, I see. This one doesn't actually talk about. It has that as a dev dependency. Ah, I see. Okay. Which is what I got wrong. Let's try it now. There we go. So if it's a dev dependency, we should probably run the tests for this, and then we'll put out a PR for it. Hope everybody had a good week. It's currently smoky and miserable here, so we're all inside. Nice, okay, so that worked. Just make sure. So yesterday was my streaming cake day. 1 year of streaming. Over 1,000 hours of streaming Rust online. I think I'm at 1,100 now. But it was more than I expected to get in a year. I just really like Rust. Alright, now we're going to see if we can actually use that. So this is our game server code. Game server / client. For the noise generation, we use it on the server and the client so that we don't have to transfer an entire zone to a client. Basically, because the zones are procedurally made, we just give the seed information to the client, which works pretty well. So inside of Cosmos, which is our kind of world creation crate, Leon is going to be equal to path // Leon. You know, I could have done that in an override, couldn't I? The bottom of this, we can patch crits IO. With Leon. And minty features. The mintiest. Give it a quick check. So that 133 error, or 113, the error on line 113, we're trying to get rid of. We want to be able to convert a point point 2, mint point 2 into a Euclid point. Let's just make sure. There it goes. Hopefully that error goes away. No? Yeah, we should be able to do that. Because I thought that Euclid had a feature called mint that we just plumbed in for that. Okay, where else? Status. I don't think you should check in the cargo.log file for libraries. Seems a little odd. So where would we end up using this? Who uses Euclid? Geometry does. And path and tessellation. Oh, that's from geometry. So it looks like it's inside of geometry, and geometry re-exports it. There's Euclid. And depending on this should have turned on the Euclid feature flag. Let's make a little test inside of here somewhere. Do they have integration test? No. Here's some utils, etc., triangles, lots of tests. Very nice. Oh, look at all those tests. Interesting. Should we require mint for that? No, we can do whatever we want at this moment. Worry about how to do the PR later. This feels really silly. Let's point, or mint point. So we should be able to just call into on that. Now, does Euclid re-export mint? Because, I mean, technically this test should fail. Alright, so if that's not failing, try it out. Cargo test that. Interesting. It's doing a big check there. So why was Cinderella thrown off the basketball team? She ran away from the ball? Didn't she? Alright. There we go. What version's mint at? There. This should fail. Oh, cannot. Features and dependencies cannot have the same name. Oh, I see. We have to rename that everywhere? Fine, we'll rename it to Euclid Mint. Or Minty, or something. Never trust math teachers who use graph paper. They're always plotting something. Oh, good one. That's a good one. All right. Yeah, we're gonna go through these pretty quick. Features. All right. Edit anyways. Cargo check. But Euclid does not have these features. Since when? What version of Euclid are you using? Oh, Euclid Mint doesn't have those features. That's correct. Euclid Mint should just be Mint. There. They figured that out really quick. So why did the picture go to jail? Why did the picture go to jail? It was framed. All right. I think I've got 2 editors open, causing havoc. All right. Good. That's an error we can deal with. 656. I just want to see that this will work. See, the workspace isn't quite right here. Because the top levels is a package and a workspace, it's not quite right. I didn't realize that you could actually do that. I'd always treated the top level, like if you have a workspace, it's a workspace. It's not like a blended workspace and package. Which is kind of interesting. Wonder if there's a decent use case for it. Hey, Dusty Posy. How are ya? Happy Sunday. It's interesting that it automatically removed the other workspace elements. Pudding Senpai, good morning. Just came here from a Go stream. Otherwise, you're fine. I'm doing well. Yeah, so this is a workspace and a project. Wow. You can tell looking at this cargo file. Normally, well, this is the first one I've ever seen where they have a package defined and a workspace defined. I'm doing pretty well. I'm glad that there's like a direction that we can go in for this. Everything compiled. I just wanted to see it compile. Make sure. Okay. Now we have to change our feature in the game server. This is Euclid Mint. That's the override. In Cosmos, we need the same thing. There we go. You saw WGPU? Yes, yes. We're actually building. We're trying to build triangles to give to the game client. So we have our shapes here. Now our shapes, we're trying to convert the points. We could just take X and Y out of this, and I probably should, because at this point I've spent way too long trying to convert these things. But this conversion should exist. And Mr. Wormhole has had a bad experience cleaning up after cleaning up some Go. All right. Yes, we did remove Spade. I'm expecting those to be gone. That's fine. That's fine. That's gone. Fine. Don't care. We'll get to you. But these down here. Oh, for I-32. Really? The points on Builder are floats. Oh. Didn't we have 2F64 on... No, we had Cast, didn't we? Where's Cast? Okay, I didn't realize we were going between ints and floats. Because yeah, that's not going to work. F32. Now this can store a fixed number of extra F32 values per endpoint. All right, because when we do the scan through the noise, and we try to determine when we cross a threshold in the noise that we will use then to build these islands with, we do that all with ints. They broke API with the new 0.6 update. So you're trying to update cache in your head? Ooh. Good morning. All right. So, unfortunately, we went through that, did all that work, only to find out that we cannot do this. I just want to check real quick. Let f point 0.2 0.3 f32. Y is going to be, so if we had that, could we add that to the builder? F point, it should bail, good, because they're not the right types, but then we could do an into on that. Yes. Okay, well, it looks like what we did worked. I'm going to put out a PR for this status. Cargo toml */cargo.toml. Yeah, we're not going to keep that test. Do I use COC? I do use COC. Let's see, adding Euclid Mint. Feature flag to enable Euclid Mint. Should we add the cargo.log file? That seems odd to me. Because it's a library. It was already there? Did anything really change? Oh, you know what? We don't want mint in there. That dev dependency here we need to get rid of. There we go. Okay, let's append that. Your analyzer plugin throws errors when opening a new code block. Ooh, really? Are you using the kind of weekly Rust analyzer? Am I using Oh My Zeesh, Oh My Shell? It is. Hold on. I have to look in the. I thought we had it in. Oh, it's called Starship. Yeah, this here is all Starship. Prompt. So we'll do geometry cargo and save that. Cargo check. Cargo check. All features. All features. Now with the correct spelling. Yeah, purge it and read. Maybe. That's odd though. Have you updated it? Are you using plug? Actually. I wonder how far behind I am. Yeah, it looks like I'm on the latest weekly. Starship's faster. Push this. We'll do a little PR. Now, we're going to go into a little bit of a PSA, public service announcement. There are a lot of crates out there. So if you don't know what to do in Rust, there are a bunch of crates like Nika Leon that have easy and kind of beginner tasks and tasks marked as need help. Let's see, and this is going to base 16. Wait, why is profile? We didn't add profiling. Okay, that's from something else. We need to fix profiling on there. And profiling there. So tessellation had profiling. We do not want to add that. Okay, I butchered that merge. That's why you always check. Always check. And then also in the base cargo file. There we go. Okay, that. Let's patch that. Cargo.toml and tessellation. Cargo.toml. There we go. Amend that. Git push force with lease. Debating whether to switch from spaceship to starship. Yeah, I like it. Does spaceship require that you use certain nerd fonts? Alright, that looks a little cleaner. This shouldn't change anything. You know what? I think the creator of this repo also works on Euclid. I'm pretty sure they know about Mint. Yeah, look, forks from Euclid. Okay. All right. Well, for now, we'll just use whatever we have locally. Nerd fonts, yes. Nerd fonts. All right, so that's done. It's unfortunate that we have to go from our current points into F32 points. Powerline font? Oh, what's Powerline font? That I've never heard of. Ah, fonts for Powerline users. Makes sense. Wow, look at all those. So what's the difference between Powerline fonts and nerd fonts? All right. So this point here is a point, it's a vector of points, point twos that are I32s. And if we want to take these into that builder, we have to do something that's slightly different. Now, I thought we did have a point type here. Yeah, that is, okay, the wrong type for us. So we're going to do the conversion in place here. Morning, Noob Giraffe. How's it going? And thank you, Surfcat. I see, so nerd font is a superset. I did. I mean, the size of the font was just gigantic. Like, it's a huge download. All right, so let's get some coding going. Does Cosmos have Euclid? It doesn't have Euclid. Oh, it does. It's right there. All right, so the first thing that we have to do is we have to move to the first point, and then we have to line to the rest of the points. But the types are wrong. So, F32, unknown unit, and the X and Y here. Actually, we could do it this way. Or just point 2D. Yeah, that should give us the first one. Let's pull that into the namespace, into the space. You remember when VS Code was hyped and everyone in the family jumped on it now? You know, for me, I tried it. It just seemed a little heavy. That in like early in my career, I was doing a lot of sysadmin work. And it's just nice to be able to go in a box, always have something like VI or Vim available. All right, so we can do that. And the first point here, we say 2F32 on that. It'll do the cast for us. All right, that's not bad. Now we'll do the line 2s on the rest of them. So points, not the first one, so we'll skip 0. So for every other point in there, I want to convert it into kind of the same sort of thing here. Then once we have that, we will do a builder, line 2. And we'll give it the new point. So pt dot f32, and then we're done with the builder. Type annotations needed? Really? That should be borrowed. Can we even do that on a slice? Yeah, one of the things with Vim, there's a couple of tutorials. I think there's Vim Tutor. There's also Vim Adventures. Which I have to admit, I did pay like the whatever prices, and I made all my kids go through this because when they're coding on their machines, I can't use their editors. I just can't. So they're all using Vim. Ah, all right. But you can get a little ways in here. You can move around. It'll teach you through it. It's fun. So you go through, you talk to these little things, you get better and better at Vim. They do have like a paid for thing. Buy a personal license, and the personal license only lasts so long. 6 months access to Vim Adventures, $25. I mean, it was a decent way to get kids into actually learning Vim, because it came across more as a puzzle game. All right. Why? Point 2D from point. Type chord. Should have known that. Why can't you do that? Oh, because it's borrowed. That's so silly. Clone not into. I don't even think we need that one. Oh, in the Vim airline? Oh, sure. That's so in the dot files, there's a COC status. So yeah, once you have COC in there, you can have COC status mapping to that. Okay, so that works. There doesn't matter. Twitter. It's not confident. Okay. So what do we do after that? We're trying to get this. You know, then I spent a bit of time trying to get I spent too much time trying to get that feature pipe through, and now I've lost my kind of context. We're doing this. So then we call build, and we get the path back out. That's why. That's right. We were returning a path. Good. Was it finish? Oh, dot build. That should return a path. Are there any other optimizations we could do with this? Yes, there are. We can avoid that clone. Because we take the first point off, we just pop that. Oh, no, that's, we want to remove it from the front, don't we? Ooh, but we don't want to shift all that. Don't really want to do an allocation here. So points here is a vector. It's a vector of 0.2 I32s. The first one we want off of there, but after that, we just want to take ownership of that slice. I'm okay discarding the last thing. If we do a remove, we shift everything. There's probably going to be small. It's a mem move, right? Because if we did retain, I think this actually reallocates, doesn't it? It creates a new vector. Oh, operates in place, visiting each element exactly once. And preserves the order. I think it's... Alright, that's not super efficient, but it'll work. And then points here. We get the intuitor. In which case we don't have to do the clone here. Nice. Okay. Unless there's something on slice. These are nightly, aren't they? Yeah, those are nightly. Split at, etc. No. To vector. And that's just a copy. Okay. Is my game ready to play? It is not, sadly. We are currently working on building islands. So we take some noise. The noise gets traced. We create a shape with that. Now we're basically taking the points inside of the shape and putting them into a path, which is used by the tessellator to create triangles. Alright, this can go away. We're not using spade anymore. Alright, so when we call this, we want to get a path for this instead. So for a given shape, let path equals shape dot, I guess, into. So now it has the path. That's this path here. Yeah, we could use our own points. Got it. So we create a new vertex buffer and a fill tessellator. Alright. Interesting that this is inside of that block there. I wonder why. Alright. So we basically want to do this. So we'll get rid of these. We'll have to collect the triangles out somehow. That's a fill tessellator. and the vertex buffers. Now, actually, this skips an entire step for us because we skip the triangles altogether and go straight to the vertex buffers. Oh, interesting. That saves some. That means that every 3 is actually a triangle. Okay. So if every 3 of those vertices in here is a triangle, we should still be able to build the pathfinding information from that. Alright, my vertex doesn't exist. If it did, we would just be using the types from Mint or Euclid. I guess we could use the Euclid types here. Point 2D. Those are going to be what, F32s? A known unit. And why the U16 on the vertex buffer? Import that. Import that. Fill options, we need to import as well. Oh, come on. Lots of imports going on. Oh, missed one. All right. So we have our geometry. We're going to be building multiples of those. So basically one of those per shape that we detected. Okay. Now the return type is incorrect here. It's fine, we'll get there. We want to return geometry. Pause as a point, a game type. That can't be it. That's not the right type of point. What type of point are they using? They are using a math point. What is that? Hey Rockaboo, how's it going? What does this point have in it? It's a Euclid point. Okay, it's an F32 Euclid point. In that case, we don't actually have to give it anything. We could just give it identity. I guess the fill attributes could be useful. What does buff builder want? It wants a constructor for these new types. I see. Okay. Then we collect into the wrong type, which is okay. We'll just build this back up. So we're going to need probably some sort of type alias for the geometry. Let's capture that there. Let's go to the definition of zones, because geometry is no longer like this. See, that there was a mesh. We will say it's basically this geometry Ooh, interesting. So previously on that mesh type, we were able to calculate how much area it had inside of it. And the reason we did this was to remove small meshes, small shapes. We could still do the same thing, but that is a vertex buffer. What is a vertex buffer? It has vertices and indices. Ooh, no way. It actually has indices as well. Oh, that's so nice. I see. So one of them is the output vertex and the other one's the output index. And here we're using a U16. We should never have more than 64K indexes into that mesh. Okay, that's good. That's really good. The question, though, is whether or not those vertexes are duplicated. If this is set up to directly go onto the GPU, then they would not be duplicated. Basically, the vertices would be unique inside of there. I wonder how they duplicate those. Alright, well, let's not worry about that. It does mean, though, that as we go through this, we need to not iterate over the vertices, but we need to iterate over the indices. We'll create a triangle out of it. So basically, get the 3 verts and calculate the area for that. Okay, so let's build some triangles to calculate the area. So given the indices, and we'll iterate over them. Now we want a window. Windows 3. So we'll look at 3 at a time. Oh, no, that's not going to work. We basically want chunks. Returns an iterator over chunk size elements of the slice at a time, starting at the beginning of the slice. So there should be multiples of 3 because we're dealing with triangles. Now we can iterate over that. What is chunks? Does it return an iterator? Yeah. And given the iterator, we want to fold on that. Or we map, given some value, we'll say unit, I want it to tell me what the type is. And then we will sum the rest of that. So for each one of these triangles, or indices, we have to look up the vertex, convert those to points, which can then go into a triangle, etc. And we get this size. U16, okay. It's an array of U16, okay. We'll just say it's indices there. So given that, we'll match the indices. If there are 3, A, B, and C. Oh, you know what? No, let's not do it that way. Let's get the vertexes from this. So we're going to map those indices. We don't have to do anything fancy for that. And that'll be self.vertices I. So basically we're converting every index into a vertex. Okay. And then convert that into a triangle. We'll call area on that. Convert it to a U size. What cannot be indexed that way? Oh. It's going to want the cast in there. There we go. Now it'll tell us that there isn't any from here, which is fine. This needs to be interesting. What could we collect this into? Can we collect it into an array of 3 vertices? What are the types of those vertices? It's an output vertex, so it's whatever we say it is. So point 2D. All right, so this is what we're looking for. Now we need to convert these a vector of Euclid 0.32s into our triangle. Let's go to the definition of triangle, down to the bottom. Simple from vector of Euclid 0.2D F32 unknown unit 1 capital D Now, what does our triangle want? It's a point. Oh, this is silly. Let's just get the area for that. Instead of that, let's just info area for that. Skip the middleman. One bracket, two bracket, two bracket. There we go. Now this line distance, it operates on F64s. That should be okay. So I'll have self.0. Oh, line distance. We just want the first 2 points there. Okay. This does not need to be in this file anymore. Take it back to here. Interesting, because that's actually what we call a mesh now. Oh, no, it's not. Alright, so we're not converting that into a triangle. We're just going to ask the verts for their area. Now with more correct type information. Okay. What else we got here? Let's start at the top. Generate island. So we go through, create noise, scan the noise for a grid, basically the data in the noise. Keep that. We pass it to transitions, looking for the outlines of shapes. Create polygons. Which is basically how we trace the outside of a shape in a clockwise fashion. Simplify them using the algorithm we did 2 days ago. Tessellate. Remove the small meshes. We might need to do this before that. I guess not. And our type is different here. We're not returning a triangle anymore. We're returning a vertex buffer. Do we want to expose that type here? I don't think I do. So we'll have the vector and then the indexes. I'm okay bleeding out the Euclid information. Euclid's okay here. The client's using Euclid. We could take that back down into a mint type, convert it to and from. I don't know if that's actually going to be expensive. But given that these things are well inside the project, I don't think it's really a public interface. So we're going to return the points and the indexes. You know, I wonder if the client would actually benefit from using Leon too. It probably could. It probably could. So I'm not going to hide that type, actually. Because our mesh is that type, isn't it? Yeah, that's a vertex buffer. Okay. Setting the triangle heights. This one's a little different because the triangles are different now. Let's comment this out for a moment. I'll have to think about that. We might do that elsewhere. Yeah, we're going to be dealing in 2D points here. We'll let the client deal with that, which means that that goes away and we return the triangles. Because I think we could just translate it in the client, the whole mesh. Okay, mismatch types. Oh, we got too many vectors. Got it. Vector, vector, vector. Oh, I thought we got rid of that. Oh, that's in a test. That's in a test. Is this our tessellation test? Oh, it is. Expected versus actual. Okay, so we need a way to go from that that mesh into a shape. Basically, mesh needs that, which is really just going to be a modification of that height one that we had. No, area. It's going to be a modification of that. So here's shape. Got some tests for shape. Good, good, good. That's our debug. Oh, that's not quite right. No, it was the other one. This one, area for mesh. Yeah, this was a vertex buffer with the points and U16 over on the right side. Okay. I got those angle brackets out of order. That one. Okay. Oh. It should return a shape, not a 64. Or a self. Even better. Okay. So given this, we're going to do basically the same thing as the other place where we're doing the chunks. But instead of a sum, we will assemble this into a shape. Let's see, is this even going to work? No, this isn't going to work. Oh, I should have thought of that. It's because the order of the triangles versus the shape. The shape is a tracing on the outside of a shape. Alright, where's our errors? So this debug, we're comparing two different types. We need to get them into types that are consistent. So we either build up a vertex buffer, like so, or we take a vertex buffer down to points. I'm leaning more towards converting a vertex buffer to points. No. Let's just comment that out at the moment. We'll add the asserts back in just a moment. I want to see this in the client. Let's see how it's going here. Okay, where are we here? We're in generate. Oh, this is in the client code. Perfect. So we've made it to the client code. So we generate an island. The zones here is a little bit different now. Yes. So we have that vertex buffer, which means what we were doing before doesn't quite... We don't have to build up the verts anymore. That's what we were doing. Colors I thought we were not using anyways. That's commented out. And the verts and indexes just go straight in. Oh, we gotta convert them. What were we doing to convert them? We're calling triangle to vertices. I see. All right. Skip that. So we're going to set both the verts and the indexes, which should be the mesh. We're probably going to need to convert those types. Oh, yes. Now, what is it saying here? Euclid unknown unit. The trait bound 0.2D yada yada GD native prelude 2 variant is not satisfied. Oh, we have to take it to a 0.2. Right, because GD native has 0.2, which I think is a type alias to a F32 unknown unit, yada yada. This should be fine. It's a Euclid point 0.2D. F32, yes, F32, unknown unit, okay. This is because we have two different versions of Euclid, isn't it? Cargo tree-I Euclid. O22.1. Not too bad, okay. GD native core wants O22.1. Leon geometry wants it as well. So why? Okay, say that again. Is there something else am I missing? Oh, it's a vector. It's a vector. It shouldn't be a vector. Yeah, those need to be inside of a vertex array or whatever it was called. Vector 3 array. Alright, so we still need to do this. So in this case, y is different. So we need to create a new vector 3 given that point. Yes, good, good. daughter asking my wife, "Are fairies real?" My wife says, "Yes, fairies are real. You pay a toll, drive your car on, and they float you across the river." Oh, that's funny. All right, I forget what the point type was here. It's a point 2D, right? Oh, that's an F32. That's the index. Oh, that's right. Mesh dot vertices intuiter. There we go. Y is going to be 0, and Z is going to be point dot Y. Because we're going from like Cartesian to 3D space. And in ours, we want Y. Basically, we want to lie put the islands down flat. So we're using X, Y, kind of in a ground orientation as the floor. They'll have a height of 0. We'll create the mesh. And then we will give that mesh a height. You basically need to transform it. Alright, mesh instance, set mesh. Okay. Can we move it? I want to know what I can do on a node. Get child, get parent, get all this stuff. I don't want the getters. Is move child. That moves it in terms of order in its kind of a parent-child relationship. Remove child RPC stuff. Set. I thought there was also like a transform bit. Oh, can translate. I see. So I should have been looking on object instead. That's odd. Huh. Okay. Let's go back up to object. Actually, let's go into Godot. Godot will tell us the secrets. We have transform and translate. Translates on a node 2D. Ah, what is it called on a spatial object? Oh, it's there too. Translate. Function. You give it a vector 3. Okay, that's perfect. Now we can just adjust the entire thing and move the entire thing up, which would be good. The other thing we have to do in here is set the owner. Set to owner. Owner. That's right. Now this is going to be the height. Vector 3D. new. X is going to be 0, Y is going to be some value, and Z is going to be 0. Okay, but what should that Y value be? Enumerate. Oh, that's not correct. Should have been over here. That'll just be a zone index times something. It's like 8.0 times zone index as underscore. All right, that's not bad. We need one more parenthesis. Then we add the child. Oh, do you not know what a vector 3D is? Should be that. Unicode type or module, Euclid. All right, so we didn't have Euclid in here. Does it have from? All right, so we just into it. Just gonna drop the type info here. Just have those dot into. One too many parens now. Not bad. Oh, no, enumerate on that. Iter dot enumerate? Okay, that's right. And the indexes wanted something else. What was it? An int32 array. We're gonna undo that a little bit. So let indexes its indices into iter collect. Hope that works. You can tell us it moved. Oh, interesting. That's the wrong kind of mesh. You are so correct, Rust. Thank you. Thank you for letting me know I had it wrong. Can we not deconstruct that? You should know what vertex buffers is yet. 1, 2, 3. Okay, 1, 2. I thought vertex buffers was... Oh, no Leon there. Alright, so we need one or the other. I'm okay with Leon being over here. Cosmos. Legacy Rust. Let's sort these again there. Get a little out of order. There we go. Let's put that GD native back with its buddies. Okay. There we go. Now we should be able to deal with those independent of the mesh. So we deconstructed that. Now we have ownership of those elements independent of each other. Alright, so we have this U16 to I32 is invalid, cannot cast one to the other because of the borrow. These indices... What? It's borrowed? Oh. Because that's borrowed. That's cleaner. Okay. Now with the indices. Being able to do that took me a long time in Rust. To know that I needed to add that into there to get rid of the borrow on the other element. Oh, that should be indexes is fine. I don't know, we are converting them. Let's just reuse that. Alright. So that looks like it might actually build. Let's give it a build and try it out in the client. Why did the kid bring a ladder to school? They wanted to go to high school. How do you keep a programmer in the shower all day? Give them a bottle of shampoo that says lather, rinse, repeat. You guys got any good ones? Alright, so that built. Now we're going to go into Godot. Let me make sure that OBS picked that up. Good. Project. Quit to project list. I just have to save and close that. Come back out. Just because the DLL doesn't load automatically. For whatever reason on OS 10 it's not doing it for me. And move that over there. That up there. Load up the island scene. So this is our island scene. There's other stuff in the scene, but that's where the island is going to appear. We're going to click on this. We've got a little tool script set up so that we can just generate an island. Is it in there? I don't see it. Actually, there might be a little blue dot there. Let's delete those nodes. Yes. No, it's not there. When it is creating this spatial object, but it does. Oh, we're getting some output errors. Method panic. Check standard error. Standard error. Oh, look. So this is what we're trying to render. You can see our seed info. Size of 13. Some information here, and an island layer of 1. Alright, so shape. Got an index out of bounds. 90, but the index is 97. Oh wow, that's quite a ways out of bounds. Alright, let's go to shape 33. What are we doing here? Oh, we're calling render. Do we not have 33 points? Oh, 90. It was up in the 90s. We can't do that. That's way too many points.
I believe in reproductive rights too.
Okay, it should not have been creating that many points for this tessellation.
No. Don't order that. You're probably the last person in this room who needs any more carbs tonight.
Did that all? Because here, Cosmos Lib 151. Generate islands.
I'm not racist, but my favorite author? You probably haven't heard of him. I don't think they teach Kierkegaard in the state schools. Be right back. I just have to do a number 2.
MC Lars. You make me laugh.
Let me tell you all the intricate details about my recent financial troubles.
So we went through there, and then we tried to debug whatever that shape is.
Not counting what's probably going to happen later? How many other guys from Tinder have you slept with? take this call? It's my ex. My favorite type of music? Probably nerdcore.
Okay, let's continue. So, oh, 97, that's a character A. That's A. Ah, okay. Alright, I butchered this. I changed these from bytes to characters because I wanted to be able to use this Unicode character here. What this is supposed to do, it's supposed to print out another version of this. Yeah, it should be a grid of bytes. I wanted this very special middle dot because okay, if I use dot like a period, then because I'm using ligatures with the font, it'll collapse them into like 3 close dots, and it does all sorts of weird stuff, and I just want this printed out nicely. I guess we could use some sort of low ASCII square character. Use a hyphen. It does the same thing with hyphens. So 1, 2, 3, 4. So they change depending on how many you have. Let's use some high ASCII. Well, that's just a low ASCII. I want... Oh, there we go. You can rewrite it to support Unicode? Well, let's see, what's going to be the difference here? I did add upper and lowercase a to z. I think there was upper to begin with. I just added another one. Because you never know, you know? And then here... Oh, I see. You have to do a replace range. Interesting. It's going to be... Oh, I want to learn about this. Replace range. I see. So we give it the range, which would be a single character, and we give it a new string. Can we have a vector of chars? I mean, a vector of chars seems like it would work also. Can you collect a vector of chars into a string to display it? No, I didn't read through this last night. Just kind of dropped it in there. Now in this case, we have a flat map, grid 0 to height. Okay. Then for each one of these, we map that. Then we collect. Okay. The other option, to go back to the way it was, but use something else instead of Unicode. You know, we got other things here. What's the difference between 249 and 250? Because these were bytes before. Is it like that? Okay, toss the B on there, good. Does that need to be in quotes? Single quotes? Oh, you need the equals, okay. I guess technically this is like a OX. Oh, no, it's not. It's just 249, isn't it? It's decimal. Alright, so we'll also put the equals back on there. And this was string from UTF-8. Unchecked. Oh, from UTF-8. Oh, result. Unwrap. I mean, really, it's unchecked. We know this is all going to be. That's going to be fine. Did I do this one too? No. Okay. So after that builds, then we'll go back to the project list and see if we can get it running again. All right, there we go. One more time. Oh, we got output again. Check the output. Again. Should have just run the tests. Whoa, didn't mean to do that. Not all the tests, just the ones in Cosmos. There we go. Okay, so it's still doing the same thing. It was online. And we need a width and a height on there. There's something. I'm not calling render in that test. It's drawing X's. Alright, we'll do this one though. It's going to be something kind of like this. Oh, come on. My fingers are not agreeing with me today. Here, let's just get it working. Expected is something. Types are wrong there, aren't they? Now we're getting a UTF-8 error. Really? Valid up to 0. Fine. Interesting that the high ASCII is not valid UTF-8. Okay, well, that works. We do pluses. Does plus do anything fancy? Oh, it does. Grumble, grumble. All right, anyhow. Let's build it and run it. I want to see this tessellation in action. Underscores? They also... The font is too fancy. Ligatures. I think underscore is probably going to be better than comma. We'll just do that. At least it doesn't appear to change the width too much. So if we have 1 versus 2 versus 3 versus 4. So it's really just that double there. That should be okay. It's not like it collapses them like not equals and stuff like that. And what about underscore A? Underscore A? Anyhow, well, let's try it out. There we go. Okay, we're gonna get rid of those two. Create a new one. Did it not load the right thing? Am I compiling it correctly? Looks like it. Did it get saved? Should have. We did the test render. And that's fine. Maybe it's debug? With mid dot? Alright. Oops. So debug fails. Okay, so I have something else wrong. It says calling debug. A to Z. Cool. Only like 3 changes? Because it looks very, very similar. Bless you. Did I have empty up here? I didn't. But I think the bug is actually coming from my invocation of it. Hey, Max on Ion. What are we doing now? We're trying to get the debug code correct. I think that the debug code was working just fine. But the problem was I'm calling it incorrectly. I think as I'm going through here, probably off by 1. So I iterate through the points, trying to capture the max X and Y. That's a weird fold. Yeah, I think I would normally use tuples here. Just trying to get the outer bounds of the that grid. Oh, you want a bad joke? What happened to the frog's car when it broke down? It was towed away. Okay, so that's correct now. Oh, lovely. We are working on the tessellation code. Now, I want the max W and the max H. So I want them independent of each other. They gotta jump. That's a good one too. Why did the can crusher quit his job? Because it was so depressing. Sorry, that's soda. So depressing. That's max for both? Oh, that's cool. Okay, we're gonna learn something new here. Interesting. So we can have a tuple of two elements. So what you're saying here is that the max on that, wow, I've never considered this. Oops. So we have a closure, and we return p.x with a p.y dot max. That is cool. So we get 3, 5, just 3 and 5. Wow, okay. That is neat. I didn't realize. Wait, it's wrong? It's doing a partial OR. Oh, got it. So do we still need the fold then? Because it's treating it the tuple as a type, not as individual elements. Oh, okay. E.y.max y. Oh, with the fold. Nice. Okay. Nice. I like your naming here. I like width and height here. And if we deconstruct this, What am I missing? Oh, on the type, the point two. Naming things, off by 1 errors. Oh, comma before the closure. Thank you. What was that joke? I just butchered it. I'm sorry. Uh, can we not deconstruct it there? 00, comma, 132, XY. Do you have to do the turbo fish here for the deconstruct in that location? Yeah, you gotta do the turbo. Oh, no more max. No more max. Just put a ampersand before the point two. Got our width and height there. That's good. All right. Debug. I think it worked. Yeah, because it failed the test, which is fine. We're okay with that. Go to save. Project list. Yes. Legacy. Here we go. Okay. Let's find the file system. Lower left. Get the size correct. Make sure OBS picked up the transition. Oh, it didn't. It did not pick it up today. I'm glad we checked. Okay. Load the island scene. Scenes. Debug. Okay, let's get rid of that last spatial. Generate. On. Generated something. It looks like a shape. Wow. The lines are like exactly on top of the other lines, but I think we have all the lines. Let's show. Uh-oh. It's upside down. That's unfortunate. I didn't want to. Because what we were trying to do is something like this. Oh, look, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. We're going to generate another one. So we'll delete that one and generate it again. Ooh. Does this one have... No, not rear. Let's go below. Bottom view. With overdraw. Oh, and this one does have the convex section on it. Very nice. The problem, though, is the order of the triangles. We have to reverse the order of the triangles. Okay. So the indices, every 3 of them, we need to swap A and C. So for every 3, where was that? Here. Good morning, Hypermanu. There are some things that you can't yet do, and that would be, I guess, a yield and await. Basically, you can't yield for a signal, but just about everything else you can. We've actually written a little bit of code to fill that hole. Oh, nice! It draws 0 to 9 header left margin, so you have the coordinates. Oh, that is really handy. And Hypermanu, the other thing that is not there is kind of the cooperative multitasking that they do, right? They basically have, I guess, coroutines that you can yield, etc. So for that, we have built in this GD native AXT crate the ability for you to fire up a runtime using a local executor, using async exec, that is driven using the tick. Also, let's go back to, for being able to accept or await signals. So you can do you can say, hey, I want to await this signal.on object and the signal name. So it works. So given these 2 things, I don't think we're actually missing much. There are, I think, some string manipulation functions that are missing. It doesn't work too well above 10. Oh, interesting. Yeah, it fits on my screen. I don't think that I think that the way it is perfect. Because we hardly ever have gigantic triangles that we need to do that with. How long have I been using Rust? A year and a day. Before that, we were mere acquaintances. I knew it existed, but didn't really do anything with it. And Museum's been helping me actually learn Rust. A fantastic mentor. And I have no idea who Museum is. So, thank you, Internet stranger. It's funny, Museum, I think you are now the person I probably know the most and the least at the same time. Like if there was a Venn diagram of those 2 properties. All right, so we need to chunk this maybe and collect it. So we need to swap these. Every 3 of these indices is a triangle. And I think if we swap 2 of the values, because it's basically going clockwise instead of counterclockwise. All right, I want to draw this out before I make this. This is my blackboard. So if we have A, that's obviously an A. We have B, we have C. And currently it's going CBA, CBA. So it's going this way. We want it to go the other way. We can just swap the first two. That'd work. So we're going to call chunks. We want chunks of 3. We're going to map those. That returns an iterator. Triangle. It's interesting though. I mean, would it be better to just iterate over and just say swap these two? Or to do chunks on it? There's multiple ways of doing this. Because we could just give it 2 elements. Just do a bunch of swap operations. What if we did this? So we left that alone. Oddball, welcome. Or is that an I or an L? My font is not being helpful. It's either a lowercase L or a capital I for me. And good morning, happy Sunday. Okay, great. It is an L. How was your stream? Hope you're doing well. We are currently working on the process of getting these meshes into Godot. We are generating islands, essentially. And today we've been testing out a new tesslator. 74 viewers. Oh, wow. It was great. Good. So what do you mainly do on your stream? And how long have you been streaming? So I'm going to have a range here. So 0 dot dot up to and including, no, just to c's.length chunk 3 for each. You're working on type racer? Oh, very cool. A type eraser app for open source code. That is cool. That's really cool. And we've done that before, where we end up having a kind of a typing challenge. Learning some sockets. Nice. Very cool. Yeah, stick with it. Streaming has been great. It's been really, really nice. We're going to swap ABC 0 and ABC 1. Now you should tell us that... Oh, there's no chunk on range? Chunks, plural. Oh, well, that's unfortunate. I'll have to do it like the old-fashioned way. Oh, range has step by. Chunks is on slice. Oh, thank you, Museum. Step by 3. Oh, I see, because of the range. And so we get a value that's use size. Oh, good. Okay, so index, and then we just have index plus 1. That needs to be mutable. Do you also get the first value? First element of the iterator will always be returned. Okay. Ooh, if your step is 0. Alright, let's give this a test here. That's not the right size. That's the right size. Let's load that scene up again. No, is it gonna panic? Condition, owner underscore valid is not true. Oh. Is that for one of these? Or... Oh, good, we got the orientation correct now. We were below it. That's good. Okay, let's delete that one. Oh, that's not too bad. And if we look at the vertices, or the tessellation there, I mean, it looks really nice. Delete. And again. Oh, nice. This one's a cool one. Okay, so I think we fixed our tessellation problem. We've got another issue it's complaining about in that the owner is not valid. I think this is because this is a simple change. So here we set the owner before giving it a parent. So if we do that, then we should be able to click into the to those elements. Can we do that? No, we can't. How do we set owner on something if we can't set its parent? I mean, we have to add owner add child mesh instance. What does add child want? Interesting. So it wants a node. We have a ref to a mesh instance. I mean, we could clone the ref. Is clone on ref? Should be. No? What can we do with the ref? So that has an Asgard, or Asarg, and a T-Ref? Does T-Ref also have Asarg? Does. So the ref, we could assume safe on it, and then we would get the T-Ref from it. Does assume safe consume it? No. Does that exist? Okay, so first into shared. And if we take it into a shared ref, clone is implemented. That's only for non-unique thread access, where T is a Godot object. So that should have worked. Copy. Okay, so if we take it to shared, if we do a new shared instead, then we have copy on it. Is there no new shared on this? No. Into shared. Alright, so we'll do that after those. It's odd that we can't add the child and then set the owner. This feels really odd. Because we'd have to do a assume safe on it. And then it would work. I wonder if there's a better way to do that. Because a new here is going to give us a unique instance, which is exactly correct, right? Because we're creating it. We are the owners of it. It's not shared. And at this point, we make it shared so that we can give ownership of it to the game engine, but still keep a reference to it.
So fragile, like it was built
Hmm.
to break off the handle. How'd we get to this place? We're leaving
Alright, let's see if that works. So I want to see more of those elements in there. Load that up. Go back to the scene. Delete the old one. Still not. Oh, no, it's fine. So this spatial. If we save and then close the island and bring it back, is it still there? Nope. Alright. Okay, that's pretty neat. Let's get the island generation cranked up a little bit. Now this translate on those mesh instances should have been there. Well, the Y is basically not set on any of these. Zone index in this case is 1, or is 0. Alright, so we have that. And island parts, when we ask it to generate an island, let's go big. Let's say we want island size to be 121 with 7 layers on this. I'm feeling lucky. Let's go 255 with 9. Okay. See how long that takes too. Project, quit to project list, save and close. Load up that DLL. Give that a quick resize, good. Alright, OBS is with us still. There's island. Now we're going to zoom out a little bit. Island. Generate. It's a big island. Ooh, it's taking a while. Uh-oh. Oh, we're printing it out. Holy cow, we're printing it out. Alright, here's our island. The different layers there. If you have fewer layers, then you don't get these little slivers. That looks not too bad. And I think we've pretty much solved the tessellation issue. I think some of these are going to be great for pathfinding. Some very long triangles on some of these. It's okay, we still need to cut holes. For instance, it's hard to see here. You can kind of see a shadow. Each layer has a shadow on its shape below it. And that shape below, should end up cutting a hole inside that shape. I don't think we would ever have island height of 7. Not like this, unless it was just gigantic. Alright. Trying to get some of those debugs going. Overall, I think it looks decent. Alright, let's bring the height down on this. And try to get those holes working. Let's say it's 31. Has to be an odd number. We could pass those in. Just haven't bothered to. Okay, so it'll be smaller. There's that. Let's get that compiled just so that we can see what's going on. Let me get rid of this island here. Give that a reload. Load that up. Okay. What? Camera. Just want some perspective. Cinematic preview? What did I check? Oh, okay. There we go. Focus origin there. Alright, there's our island. Interesting, it doesn't have any altitude. Is that correct? Yes, it's correct. Only ones. Okay, again. Ah, that one too. Still none? Wow. None of these have a height. Did I provide the arguments wrong? So we call generate island. That had been like 8 or 9 before. Just getting a bad streak of land? As it could be. Okay, let's try again. I'm not like way out there somewhere. Strange. So if we follow that through, that land size should be going into generate island grid. Lands here. We'll get the island noise value. Did I hard code the height the other day? I did. And it's still hard coded. But for whatever reason, when we give it a height of 2, we only get 1 layer. So alright, it should have built. Just reload it. Project, quit, save and close. Because now we're going to try with 3. And if we have like this weird off by 1 here, it'll be okay, but still. Okay, let's clean up these down here. Yeah, now we got 2. Oh look, it actually did do the cutout. Interesting. Set you aside. This one, we didn't get any altitude on that. That's okay. You go over there. Oh, that upper piece here is higher up. And they are being cut out, but we're not getting a hole. These are edges. Alright, gonna move that out of the way. I want one with a hole cut in it. Come on. That one didn't even have one? Lots of little islands. Nope, just shifted that one, slid everything off of it. Alright. I think we need a larger island to kind of capture this whole. Say 121. That should give us a hole in it. Doing any division or multiplication with different types? Yes. Yes, we are. I wasn't going to dig through that one yet. I want to focus on one problem at a time. So, we'll come back over here, get rid of all these spatial elements. Delete them, yes. Project list, save and quit. Reload the DLL. Actually, I have to quit Godot this time. Godot's busy crashing. I'm gonna start it again. There we go. That's better. And it found it. Good job, OBS. Maddie Live, thank you. All right, there we got one. We might go over this later with the curves. Let's see the wireframe on this one. Very long pieces. They would probably pathfind really well, because it would combine these into polygons, convex polygons. But right in the middle there, that duplication is not supposed to be like that. It looks like it's a mesh sitting on top of the other mesh, when it should have been cut out of it. So how are we going to figure that out? We need to know that this mesh is overlapping with that other mesh. It's either that, or we say this whole thing is one thing that needs to be tessellated. We could try that. Is that going to be in shape or Osmos lib? Tessellate here. Yeah, in this case, we end up iterating over the shapes there. Maybe. All right, we have something that's working. I'm going to commit it, and then we're going to make some modifications to it. Okay. Let's double check. Those look good. Good. Commit -m. Okay. Delete our buffers. Uh-oh. Which one wasn't saved? This one? Oh, that was just a debug thing. That's okay. All right, so going back to generate island. Generate island. Tessellates it down here. Now I'm hoping that this fill tessellator can punch holes through. I think it can, because of what I've seen in their docs and their examples. I'm not sure how yet. So we're going to move some of this up and out, like so. And the tessellator will work on that. And instead of returning, that's going to bubble up, isn't it? A vector, a vector, a vector. We'll return something else. So this collect isn't collecting into anything anymore. This is more of a for each. For each shape, we tessellate it. Then we return the geometry at the end. Okay. Yes. You want a different shape. Let's adjust zones. So each zone would have a mesh. Meshe. What is this? What's no longer a vector? Vector, vector shape. I thought that goes in here. Triangles. What are you returning? Vector, vector mesh. All right. We'll call it zones at that point. Remove small meshes. You are not being used. I think. We'll see. Oh, it is. Oh, that's not going to work anymore. That's just not going to work. Because now it could be a gigantic mesh. I'll comment that out for now. I want to see if it'll punch holes first. We might come back and re-enable that. Okay. Fairly straightforward. Okay. What do computers like to eat? Microchips. Yeah, that just happened. All right. Let's reload this. Quit to project list. Save and close. All right. Load up the island scene. Remove the one we don't need anymore. Generate a new one. There are no holes in this one. Try again. I think there should probably be holes in that one. Facial. This one should definitely have a hole there. On the left, where that overdraw is on the bottom. Here, we'll move in there. Right there. That is shadow. Should have been cut out. It feels like it's still creating new meshes. And when we tessellate the island, we get these polygons. Vector, vector of shapes. And at this point, for each shape that's in there, we add that to be tessellated. That's going into the same geometry buffer. Aperture science. Morning, Tommy. Happy Sunday. It's a little off topic, Tommy. All right. All right, let's go look at this here. I think we should probably do the whole stuff tomorrow. I gotta get some other stuff done around here. But this has been good. We switched to the new tessellator. I actually think that we should start to investigate having curves instead. I think that might be really, really cool. And have it tell some of that. 6:30 is the best time on the clock, hands down. Oh. Okay, who do we want to raid today? We could raid Brooke. What is Brooke doing today? Ask questions about programming. Huh. Let's raid Brooke. One check. Let's see. Alright, so science and tech. Working as a newbie Rust course. That's cool. What does it actually say in this title? Oh, okay. We'll go ahead and do that. How do I spell his name? Brookzerker. If he needs people to test that out, should have my kids go through it. Get some good questions. Like, where is the D key? All right, y'all. Well, thank you. That was fun. And I'm glad that it worked. And welcome to everybody that's new. All right. And if we can, let's see if we can see if we get enough people saying stuff as we enter. Yeah, we're gonna end.